To calculate the kilowatt-hour consumption of motors, firstly, you need to understand the fundamental principles involved. The process begins with gathering data from each motor, specifically its voltage and amperage. Multiplying these two values provides the kilovolt amperes, or kVA, which represents the apparent power drawn by the motor. Secondly, to determine the actual power consumed measured in kilowatts, or kW, you must account for the motor's power factor. The power factor is the ratio of real power, kW, to apparent power, kVA, and indicates how effectively the motor uses electricity. Multiply the kVA by the power factor to obtain the kW. Thirdly, with the kW established, you can calculate the kilowatt hours, or kWh, which represents the energy consumed over a specific period. This is done by multiplying the kW by the number of operating hours. The resulting kWh value indicates the motor's energy consumption during that period. The runtime percentage affects the number of operating hours used in the kilowatt-hour calculation. If a motor operates at 92% runtime, this means it operates for 92% of the total hours in a given period, such as a year. To determine the actual operating hours, multiply the total hours in a year, which is 8,760 hours, by the runtime percentage, in this case 0.92. This results in approximately 8,065 operating hours. To calculate the kilowatt-hour consumption for a motor with a 92% runtime, you would multiply the motor's kilowatt rating by these adjusted operating hours. For smaller motors where the power factor is unknown, estimating the power factor is acceptable, but it is important to understand that the accuracy of the kilowatt-hour calculation depends on the accuracy of the power factor used. A typical average power factor of 0.80 is generally appropriate. Here's an example calculation. Assume a motor has a voltage of 480 volts, an amperage of 20 amps, a power factor of 0.85, and a runtime of 92%. Firstly, calculate the kVA. The formula is kVA equals volts times amps. So kVA equals 480 volts times 20 amps, which equals 9,600. Secondly, calculate the kW. The formula is kW equals kVA times power factor. So kW equals 9,600 times 0.85, which equals 8,160. Thirdly, calculate the kWh for the runtime. Formula is kWh equals kW times runtime in hours. So kWh equals 8,160 times 0.92, which is 7,507 kWh. Therefore, the estimated total kilowatt-hour consumption for this motor, assuming a 92% runtime, is approximately 7,507 kilowatt-hours. Repeat this process for each motor using its specific voltage, amperage, and power factor data to determine its individual kilowatt-hour consumption. This method provides a reliable estimate of the energy usage of motors, aiding in energy management. Firstly, ensure accurate voltage and amperage readings, and secondly, if available, use the exact power factor specified on the motor's nameplate for each motor.